Hello, everyone. This is the first part of streaming week with Kafka and Python examples. Ankush, I know Ankush already gave lots of information about how streaming concepts works, how we can implement things in the Java. But in this session, I will be doing similar kind of producer-consumer stuff by using Python libraries. And for this one, I tried to make it as much as aligned with the Java examples that Ankush already showed you. And I will cover that up during this session. And as a difference from what Ankush did, he was using Confluent Cloud, but I will be using Docker, and we will be running Kafka-specific services in our Docker container, rather than using an external Confluent Cloud setup. Let's start. As I said, we will be using a Docker for running examples in this tutorial. And for this purpose, I created a Docker folder which has Kafka and Spark underneath. For this first part of this tutorial with streaming with Python, we only need Kafka services up and running. Therefore, let's go and check what kind of services we have in the Docker Compose and what kind of configurations we need in our system. As you see in services, we have broker, we have schema registry, we have Zookeeper and control center, and we also have Kafka REST. The first four services are necessary to able to run Kafka successfully and without any problem. But Kafka REST is kind of an optional service which allows us to communicate with Kafka broker using the REST API. I just added it because sometimes whenever we are debugging the messages or whenever we need to understand if everything's going correctly, we may need to access it through REST API. To able to run this, start everything, the only thing we need is to have the specific network configuration exist, because I normally we don't need in this tutorial to have a specific network, but let's stick to creating the network as well, because this network we will need it for the next tutorial when we try to communicate with Spark and Kafka. Therefore, I would suggest you to go to README and create the network as described here in the second part, and create this Kafka Spark network. And after you run this, you should have in your Docker setup Kafka Spark network available as a bridge. Okay. And after you have it, what we can do is I will also do the same. Go into the Kafka folder and just run Docker compose up. And I will run in the patch mode. I don't want to see the logs or intermediate logs, but if you're interested, we can check out. Good. Now let me go to the Docker PS. And now all of my Kafka services up and running. Before jumping into the code Python examples, I also want to highlight a couple of parameters that we have set up in our broker, which are important for us to understand. Whenever we specify broker, we needed to define some Kafka listeners and Kafka advertised listeners. These are the parameters that we define for configuring how Kafka communicate within the Docker and how we can access broker outside of the Docker. For example, plain text is just defines, okay, this is how Kafka communicate within the inter-broker listener lane, as you say, I set up as a plain text, and this is the port that is used within the intercommunication within the Kafka cluster. And plaintext host represents how we can access to the Kafka cluster outside the cluster itself. And now it's representing 1992. And here you can see we set it up. Kafka advertises the local host, which means I should be able to access my Kafka cluster, Kafka broker by using localhost 1992. These parameters are quite important. I would highly suggest to search through it and understand why we need two different host definitions. But I just want to highlight before we started, because in our code, when we set up our Python examples, we will be using host 1992 to connect our Kafka broker. All right. Let's start with the JSON example. And before jumping in, I just want to mention it. I try to keep it as generic as possible. Like, as you see, our example has consumer, producer, and settings, and also a couple of write, record, and write record key, which objects that we will use. And likewise, JSON example also has consumer, producer, and object that we are going to use, and also settings that file. This way, I just want to make it easy I just want to try to make it easy what kind of things we are changing in between, like parsing as a JSON and arrow, and give you an idea what kind of things are the most important parts of this setup. All right. Let's start with the JSON producer. And within JSON producer, our aim is to read CSV file and create a producer, read CSV file that is in our local machine, sits in the resources writes.csv, and publish each of the row into a specific Kafka topic using the Kafka producer, which is writes_JSON. The logic is simple. We create JSON producer, we read the records, and then we publish the the records that we read from CSV to the Kafka topic. But what is important here is the configuration, because JSON producer is a class that we just create as a wrapper around the Kafka producer, which is part of Kafka library, and it expects that set of parameters that we need to pass. One of them is bootstrap servers. Bootstrap service has to be, as I mentioned, localhost 1992, which is available because we specified it as a localhost in our Docker compose. And we needed to specify how our key and values has to be serialized. It is important here, like, for example, in here, for example, our key will be integer value. That's why I'm first converting them to a string and then encoding it. Why we are encoding values is because Kafka topic is expecting messages in binary format. That's why we needed to handle this encode and converting our message before sending to Kafka in a correct format. And likewise for JSON, we are sending our object as a dictionary, but with JSON dumps, we are first converting it to a string, and then we are converting it to a binary. This serialization we needed to keep in mind, because we will need to revert it back in the same order, in actually a reverse order, when we are doing consumer key deserialization and value deserialization. All right. We created Kafka producer with set of parameters, bootstrap service, key value serializer, and value serializer. And then we read the records, and our records in format of write. and write object expects an array and parse the array in such a format that we can access it as an object in specific fields. And this write class also has a second initialization method from dictionary. Basically, it gets the dictionary and it basically parses and it creates an array out of this dictionary and create the right object out of it. And finally, I specify a represent method because I wanted to see for debugging purpose, I wanted to see our messages are sent through and read through correctly. That's why whenever we wanted to print out our write class, write object, it will first print out the class name, right, and then it will print out the object as a dictionary. This is that's why we can easily see which messages is passed through and which ones are successfully sent to the Kafka topic, right? And in the last step, producer has published writes, and it has a topic and messages, and these messages are sent through the producer through send method. And we specify key and we specify write PU location ID. This PU location ID is integer value. Let me review. PU location ID is integer. That is the reason when we are doing serialization, we first need to convert it to string. And our value is the complete write object. That's why we are passing as a JSON. We are passing as an object actually, and this object is converted to a dictionary, as here, and this dictionary dumped to a string, and then we encode it afterwards. And just as a debugging purpose, I'm just printing out our report. What if we pass it successfully? We pass this state, and it will print out the report successfully process. Let's run it. First, yeah, I'm in the Python JSON example folder, and I will do Python 3 producer.py. And as you see, it follows record and the PU location ID is successfully processed at the offset. We know all of and we didn't have any exception. That's why we know all of our messages passed to the correct Kafka topic. That's good. Let's see how our consumer look like, because we passed this into a custom consumer Kafka topic, and now our consumer should be able to access it and read it. Okay. Here, consumer logic is also, we are just creating a JSON consumer, and our JSON consumer consumed from a specific set of Kafka topics. This Kafka topic is exactly the same Kafka topic that we have used in our publish writes method, and this you can see in the settings.py writes_JSON. And there are a couple of parameters that we are setting to our JSON consumer. Again, bootstrap servers, we are setting up how we will read, how our consumer will read the topic. For example, we always read the earliest possible. It will read through all of them. For example, if you are only interested in the latest messages, we may need to set up as a latest. Latest is the default setup, by the way. And then we needed to define key deserializer and value deserializer. And here the important part is, because now we are getting message we send message as an binary. We handle the serialization and send it as a binary. And now Kafka stores this data as a binary format. And now we needed to be able to read it as a human readable format, we needed to take it back, get the key. In that time, we needed to decode it. And then we needed to, for example, convert to integer, because initially the data was integer. And likewise, we first needed to decode it for the value, and then we load it as JSON and create a dictionary out of it. And here, for example, with the object group parameter, we can automatically say, okay, I get dictionary, and this object group parameter will ensure my output will be on the right format, because I already specified from dictionary right object order has from dictionary and return a right plus, get a dictionary and return a right plus. This is how it will work. Again, in the JSON consumer, we are passing the plots configurations that we have talked about as a Kafka consumer, and Kafka consumer needed to, in the consume from Kafka function, need to subscribe topics that we have specified, and then it needs to start pulling the messages from the Kafka topic that the consumer is already subscribing. Whenever we put a message, like whenever message is not null or message is not empty, we will have message key and message value from the message. And here we can do, for example, we can write them in a file again, or we can do another processing. But here, just because it's a Kafka consumer and producer example, I'm just thinking about how we can get this, how we can read it in our console, just as a debugging purpose, basically. Okay. Because I already created the data. Now, whenever I run the consumer, it should be able to consume the available messages in the topic. Let me consumer.com. Okay, it's a bit hard to read because it's printing out lots of stuff. But let's stick to one of them, for example. For example, this 137 is the key of one of the messages, which can be the PU ID that we define in the producer. Basically PU location ID, and then we are printing the message as a value. The message value is, as you see, is right, and bunch of parameters, all of the parameters that right object has in a dictionary format. We are getting it because this message value and message underscore value, that value is basically a right object, and we define how to print out this object as class name and dictionary. That's why we are seeing it in this format. Yeah. And maybe right now, for example, the consumer already consumed all of the messages that we have sent, but let's rerun it. Let's see if it is how consumer and producer is working together when both of them up and running, because our consumer is right now active and continuously listening to the specific Kafka topic and subscribed here. As you see, simultaneously, our consumer starts consuming new messages as well as we define. And all of them happen in a JSON format. And the only thing that we need to specify is how key serialization and value serialization work together. And we needed to set that up. But in this setup, we don't have any specific schema. For example, if I go to the producer and decide, okay, now I want to pass data, but I don't want to, for example, I would like to change, I would like to still send as a JSON, but I change my write class. And my write class is no longer has a vendor ID. And I will just skip it. It will be printing out exactly the same way without any issue, because we didn't specify any schema in our system. It will be taking JSON file. It will be producing a write class out of it. But it may cause some problems, especially when we are working on the production systems. We want to make it our write class is an write class, and our messages are consistent and also backward compatible. We don't want to break any follow-up or listening systems that trust our trust the messages that we are sending out. That's why it's important to specify schemas and use our concept when we are working with Kafka streaming. This gives us confidence to make changes in our system more freely and also more controlled manner. Okay. And let me close all of them, and let's move to the our example. Again, I have a producer, and let me also stop before running it. Okay. Now we are running in our example. In our example, we will be using a different library. We were using a Kafka library before, and it has Kafka producer and Kafka consumer classes. But now, for our example, I will be using Confident Kafka library because I felt like this is more stable and more structured and more stable way of working with schema registry and our classes. That's why there will be some differences in the properties configuration parameters that we are sending around. For Confident Kafka, we will be using producer class. And let's go and check what we have. The logic is same. We have our producer. We are reading records from a specific data path, and then we are publishing it. This part is always same. It's not changing over different our example or JSON example, but parameters that we are sending around is changing a bit. For example, here we are again setting up the bootstrap servers. But we also need to specify schema registry because now we are working with Arrow, and our schemas should be stored in the schema registry, and our Kafka should be able to access the schema registry whenever the new data comes in or whenever we want to access these messages. They needed to know, they needed to communicate between each other and decide if schema is correct, if I can really parse in this way or not. All right, and let's also go to the settings because these parameters are defined in the settings. Input data path is same write CSV file. We define write key schema path and write value schema path. I will show it after going through the settings. And schema registry URL is localhost 8081. This is the pod that we are running our schema registry. For example, here it's running in the 8081. And bootstrap server, as I said, it's pointing out our broker. Yeah. And our Kafka topic this time will be writes_hour. Right? Let me also show these schemas. For example, taxi ride key. For example, in this example, our key will be vendor ID and our vendor ID will be integer value. And we are saying that my vendor ID will be integer and it's attached to record, write record. And write record key object is defined here. Oh, sorry. Here, it has a vendor ID And it again has a from_dict, another secondary initial unit class. It's basically creating the same byte record key from the dictionary, and also have similar class name and dictionary representation of the class. All right. And our write record, it has vendor ID, passenger count, trip distance, payment type, and total amount. Each of them has different types. For example, vendor ID, passenger count, and payment type using integer, whereas this is an total amount is float. And if we check the absolute value, these values has to be matching. Vendor ID is integer, passenger count integer, but trip distance is defined as float. These types plays an important role when we are trying to parse with schema registry and ensuring two services. It's kind of a contract between two services when one of them is producing the messages and the other one is consuming the messages. In our example, both producer and consumer are we define, but it's most of the time in production it's the other way around. All right. Now let's go what this write our producer does. Okay. Because we specify props and we already have schema, we need to first read our schemas based on from this schema AVCSC files and keep them as a string. And we needed to define schema register props, basically expecting URL to be set as localhost 8081. And we need to create schema register client again from the same Confluent Kafka library. And then we needed to define our key serializer and value serializer. In here, because it's an our example, I use both of them as an our serializer, but you can mix and match. For example, I think our key serializer also can be something like integer serializer, because it's only consists of one parameter vendor ID. But I just, because it's our example, I just keep it similar between each other. And both of them are using same schema registry client, but different schemas, value and schema strings. And they use different functions to be able to convert them back to the object format. Let me explain what I meant. This our serializer expects schema registry client schema as a string and predict functionality. Predict functionality is optional, but I think it's helpful, especially if you want to convert your messages directly from the object to, you don't need to parse yourself. You define a function in your class, and this function is automatically parsed message into a JSON format. For example, write record has write record to dict is basically just calling the write record object and turn it to a dictionary, for example. Just it's easy to handle when you're working with objects specifically, and it's also cleaner in the code base. And as the last step, this is the schema registry and serializer configurations, and then we have a producer configuration which only expects bootstrap server, and this we define bootstrap server as the same way that we specified in the previous example, and it will be passed to the producer. Okay. yeah, in the init class, we call the load schema. It's basically converting reading the schema definition from a certain place and then return as a string. And I will come to the delivery report afterwards. But let's see what our static read records function is doing. It's basically looking over the CSV file and create write records and write keys out of each of the row each of the line that we are reading in the CSV, and return this write keys and write records as an intermediate values basically, and this is the place that we get the right data sets in our system, and now we are ready to publish them into a Kafka topic. Right. Now in our publish class, we are getting again key and value, but it's important, like when we are reading it, we make it all of them was in the write record and write record key structure. That's why, for example, when we specify producer produce, we specify topic, we specify key. Our key is right now is write record key, and our value is write record object. And value and key serializer is aware of that, and they already know how to convert these objects directly to expected format that Kafka expects. For example, they already know how to convert them from object to dictionary first, because we defined the write record to dict and write record key to dict functionalities, and later on this dictionary functions also needed to be passed to using key schema and value schema to the string, and then later our serializer moved to a binary format. But here we don't really worry about converting back and forth in the binary format, because our serializer already does it for us. And on delivery, parameter is, for example, this confident Kafka producer defines, for example, whenever we try to produce, depending on if our message passed or failed, it's let's go to this function. It's either error or say, okay, this record is successfully built. It's similar logic that we have like printed out for logging, but it's more internal confirmation from the Kafka side that says, okay, I get this message, or I didn't get that message, or I'm waiting this message, kind of, rather than I'm trusting my Python function didn't catch an error or so. Exactly. And then we are producer flush. We ensure after produce method, we ensure flush ensures us to send the data to the specific Kafka topic. And that's it. And let's run it. And we will see something interesting in our example when we are trying to produce it. And now I'm in the Python folder again, but this time I'm using our example and I'm trying to produce some messages. Okay. Again, I get some kind of information, but as you see, I'm getting a binary message. This is the reason. This is the confirmation that we are getting delivery report directly from the Kafka side, because it says my record key is already binary format. I didn't do anything about converting or string or integer to a binary format, but our serializer already did it for us. And whenever we get confirmation from the Kafka cluster, it's already sending us as a binary. That's why it's quite hard to understand, okay, which message is being saved. But on the other hand, we also have offsets. It's also giving some kind of confidence as, okay, all offsets are incremental. That's why we don't miss any messages. This is the main difference between JSON example and this example. By using this our serializer class, we don't need to worry about the expected format that Kafka broker expects. But we are more into how we should, what we should pass, what kind of information we should pass. It's also with kind of an abstraction over our serialization. Okay, maybe I shouldn't. Let me run it again. It won't hurt. And let's move to the customer. Likewise, in customer, I'm using the same Confluent Kafka and Confluent Kafka library, but this time I'm using consumer of it. And again, I'm sending Bootstrap servers, schema registry, and schema key and value exactly the same way as a test. And at the end, we needed to say our consumer to say, okay, please consume messages from this specific topic. But let's go to the right our consumer. Here again, we are reading and setting up schema registry. We are getting the schema as string for key and value. But here, what we are using is our serializer. Again, this is one different class. Exactly same works exactly the same way our serializer works, but do reverse the process of getting the binary and converting into the expected format that we are wanting in the consumer side. And in this part, for example, because what we do in the producer is we send binary at the final Kafka, but before binary, which is abstracted by our serializer, we send it as a dictionary. And we send our message as a dictionary. And now, whenever our serializer gets the message, it needs to revert it back to the write record or write record key type. And this is big to write record key or big to write record. Does that work as part of the serialization process? Basically, it gets an object as a dictionary, and it's trying to build write record from this dictionary. And this from the method is basically a secondary in a function. And here we are specifying Bootstrap servers. Again, we are here specifying group ID because even though right now we have only one Docker and one Kafka node is up and running, in real world we may need to have multiple Kafka topics that is running. That's also to keep our Kafka topics resilient and available, up and running all the time. And also Kafka customer is feeding the earliest, again in the same setup that we had in the JSON example. And let's go to the costing. Our customer object subscribes specified topics, basically Kafka topic. This time it is Greg's hour. And This time using our key deserializer and our value deserializer exactly the same way, and we are printing out the reports. Now, even though when, for example, here we see binary output, but whenever we consume the data, we will see the real object values that we have in the first place created the messages. As you see, I'm reading key and value, and key is write key record key, and it's printing out vendor ID, and the other one is write record, and it's printing out the write record that we have here. This is how our ensures serialization and deserialization logic, and also likewise whenever we wait, it will also keep getting the latest messages as well. As you can see, the difference between this JSON and our example is just how we define serialization and deserialization, and what level of serialization and deserialization we needed to own in our code base. Our deserialization really ensures the contract between different services. For example, if your team is building the messages, and some other team is getting these messages and reading as a consumer, and we needed to get some kind of contract, and we always needed to follow some kind of schema, and this our schema definition allows that one. I think that's it from my side. In this session, we just talked about how to produce and consume messages through Confluent Kafka and Kafka libraries. But in the next session, we will be also talking about some PySpark structured streaming, and how we can handle stream data as a PySpark data frame. Until then, I think we can call out this video, and hope to see you soon for the next tutorial. Bye bye.